All right, so this is Earth 102 review. That's where we are. All right, so first of all, there are two types of tides other than high and low tides. We call them spring tides and neap tides. Now, spring tides come about because the Earth, Moon, and Sun are lined up. Now, maybe the Earth is in the middle, maybe the Moon is in the middle. It doesn't matter. What happens is the oceans get stretched by the gravitational pull of the Sun and the Moon, and they create a bulge, at where they line up. And so spring tides are your highest high tides and your lowest low tides. That should say lowest. Okay? So as a result of them being the highest high tides and the lowest low tides, you have the largest difference between high and low tides.
We need Cameron Joseph and Caden Robinson to the side, please. Cameron Joseph and Caden Robinson to the side.
Sorry, I'm doing this during dismissal. All right, now neap tides. So neap tides occur when the Sun, Earth, and Moon are at right angles. Okay, and so these have the smallest difference between high tides and low tides. All right, so if you saw a diagram like this, and you saw a really high tide and a really low tide, those are the spring tides. And if you saw a kind of high tide and a kind of low tide, those would be the neap tides. Should be an A right there. All right. But again, the kind of main thing you need to know is that the biggest difference between high and low tide is during a spring tide, and the smallest difference is between neap tides. Volcanoes can be found at convergent boundaries because of subduction. They can be found at divergent boundaries such as the mid-ocean ridge, and they can be found at hotspots. Now, a hotspot, let's see if I can move this where it's a little more visible. All right, so what happens is, whoops, just gonna erase this real quick like. All right, you have a magma chamber down here, okay, and the magma chamber is heating up and bubbling and whatnot, and some of the lava oozes up to the oceanic plate or continental plate, and it forms a volcano. Over time, the plate above the magma chamber moves, and a new volcano starts forming. And this keeps happening throughout time, as long as the magma chamber is hot enough to send magma up to the surface, right? So that's how we get chains of volcanoes, or one way we get chains of volcanoes, such as the Hawaiian Islands, all right? So convergent boundaries, divergent boundaries, and hotspots. Those are places you can find volcanoes. Deforestation can cause a loss of habitat. Because you've lost the habitat, you lose biodiversity. Because you've cut down the trees, the forest, then you lose soil because of erosion. And because you're losing your topsoil, the soil left behind is going to be less fertile than the soil you started with. So deforestation can be bad.
We need Caden Robinson to the side, please.
It kind of has to happen because we got to build homes and houses and stuff. But if it can be avoided, it should be avoided. Infiltration is the process of water moving down through the soil layers into the aquifer. So it adds H2O to the groundwater. Evaporation can actually decrease groundwater levels. And you might be thinking, but Mr. Furlow, it's underground. How can it evaporate? Well, one example would be if you have the surface and you have your water table, right? And then so this is the saturated zone. Saturated zone. All right? And so that's the saturated zone. Water can actually move up through capillary action up through the soil and then evaporate. Right? And when it does that, more water is going to follow behind it. An everyday example of this is, let's say you have a flower pot with a flower in it. Okay? So here's my flower pot. It's got some holes in the bottom for drainage. If I put that in a dish of water, the water can actually move through capillary action up through the soil to the roots of the plant. Okay? So, and then the water would evaporate from the surface of the soil. Okay? If you have if you have limited H2O resources, especially if they're very limited, there can be a lack of sanitation. Because look, if you got to walk 2 miles to get a bucket of water and walk it back to your village or your home, you're probably not using it to flush a toilet, if you even have a toilet. All right? And it can lead to disease because you're probably using water that may not be as clean as ideal. So limited water resources can lead to a lack of sanitation and increased disease. All right. Large numbers of cattle can create air pollution. Okay. Air pollution is, in this case, methane. So the cattle, they eat grass, they digest the grass all day long, and one of the things that helps them get nutrients from the grass are some bacteria in their gut called methanogens. And methanogens are bacteria that produce methane. And methane is it's a stronger greenhouse gas than carbon dioxide. So when we have hundreds and hundreds of cattle and pigs and stuff, and they're all eating and pooping and passing gas, then some of them, at least, if not all of them, are also, when they pass gas, producing methane. And the methane goes into the atmosphere, and it holds heat even better than carbon dioxide. Burning coal creates air pollution. It does. You hear people talking about cleaner coal, and I believe that's a thing. We can certainly put filters and smokestacks and stuff to trap air pollution before it gets to the atmosphere. But I don't think you can have clean coal. You can have cleaner coal. But anytime you burn coal, you're creating air pollution. Unlimited fossil fuel uses would pollute habitats and lower biodiversity. Okay? If we just went willy-nilly and had no restrictions on fossil fuel use, the pollution would be even worse than it is now. Reducing, reusing, and recycling helps preserve raw materials. Okay? So that we have those for future use. One example of this is aluminum is infinitely recyclable. And it costs 90% less energy to recycle aluminum than it does to make new aluminum. So if you only ever recycle one thing in your life, recycle the aluminum as much as possible. All right, that brings me to chemistry, but this is earth science, so I'll see you in class. Stay curious.